Okay, so after we have talked about the time complexity, the standard scalar, and the one-hot encoder, and now we want to put everything together and want to try this on a real dataset, and that is the landing club dataset. Well, I remember it was 1014 probably. I heard about that for this website from my roommate, and he suggests me if I have some extra cash staying in my checking account, and he suggests me to just put that into lending club and lend that to someone who needs the money, and then at the same time earn some interest back. Well, this is how it works. I'm not gonna lend $1,000 to someone I really don't know, right? So the philosophy is we want to divide my money into smaller pieces, so like $25 each, and then I'm gonna set up some of the standards. So for example, I'm not gonna lend my money to someone who has no job, and then I can specify I have to lend money to someone who is employed at least. Or I can say I prefer to use my money to support some of the young people for education purpose. And then, well, lending club can also allow me to set this up. And another thing is, as I said, I'm dividing the money into small portions. I'm not gonna lend a big pot of money to one person. Instead, I may cut my $1,000 into very small pieces and then lend it to 40 different people. For example, in this case, if someone broke his or her promise and didn't pay me back the money on time, it is a loss, but I'm not putting all the egg in one basket. So this is the lending club dataset and the background of the lending club. Okay, so those are some of the features and their explanations, and you can take a look on that. And I'm loading the data. I want to take a look on the header. Okay, so and eventually on the right side you will see a column the column not fully paid, and not fully paid could be the borrower didn't pay me anything back, or the borrower paid me some money back but not even the full amount of the money I lent. So it is also possible, and we want to predict this column. And here, the purpose. So for the purpose, what you will see is that column is categorical, right? So in this case, if you want to calculate the distances using k-nearest neighbor, this can be the problem. Okay, so what are we going to do? Let's create a list called categorical features, and you can do one feature or multiple feature names. And after that, we are going to use the panda.get dummies. We are going to do the one hot encoder. So we are going to apply this to the loans, which is the name of the data frame, and I'm specifying what columns do I need to apply the one hot encoder. In this case, the purpose will be the only column we consider as categorical. Okay, and then the job first. Remember, the job first means, well, for the remaining n minus 1 features, they can serve as a predictor of the remaining 1 feature. So that feature can be dropped, and then that is the drop first equals true. So after that, you can see the purpose column is already gone. And after that, for each of the possible purpose, like small business, the major purchase, home improvement, educational, those are all the possible names, all the possible categories of the purpose. And remember, one of them has already been dropped. Okay, so that is a beautiful numerical data frame. And the next part, after we have already done the one hot encoder, and we want to do the standard scalar to transform all the features into standard scales, and then we want to do the train test split. And remember, we are keeping 30% of the samples for testing purpose, and you have to use this random state to make sure that we got the same results. And we want to do a one nearest neighbor, and probably that is the easiest thing to do. And later we can also try n equals 3 and n equals 5. And let's see if we increase the number of the nearest neighbors, do we have something better or something worse? So I'm gonna stop this video here. In the next video, I'm gonna go through my solutions.